Okay, I've got everything plugged in. I've double checked my signal wiring. Also, this cable, well, you're not going to do it like that. This is just a bench test, but actually you get one of these with it where you can solder good connections on and have a good solid sound connection with soldered and heat shrinked ends. But anyway, for the bench test, I've got this, and I've labeled my signals and double checked everything. And the motor's locked in a run state. I've taken some tape here. There's a wire number I taped on here to line up the shaft, and I'm going to set that to my 0 point in the software we're about to load up and configure. So we got Windows 8.1, and we're going to go ahead and go into the MACH software. I've got the MACH loader configured for a smooth stepper board, which is this little board right here. It's inactive right now. You see the red lights on. When the green light comes on, red and blue is inactive. When the green comes on, then it's active and ready to send pulses. Anyway, there's also an Ethernet smooth stepper board, but they have a much wider frequency range for sending pulse commands. So that's what you're going to want to use, or something along those lines if you're going to run PC-based controls. That seems to be working here. All right, so I'm going to go to the MACH loader, and we'll just hit OK. And then you'll see the board light up over there, the multi-purpose optical isolation breakout board between the servo drive and the smooth stepper in my laptop over here. So that's very important. Alright, so first thing we're going to do is go in here and configure to the configure tab in the MACH3 software, and we're going to go to ports and pins. Basically, I'm tied to, with signal 6 and 7 from the drive, I'm tied to pin number 2 and 3. So I'm going to go into, you can see it, I'll go into ports and pins, or motor outputs. And I'm only going to enable the x-axis because I only have one motor hooked up. And then I've got the step on pin number 2 and the direction on pin number 3. And you're going to want to have the active low checked right there. And then, of course, port number 1 on both those signals. That's what I'm using. You have two ports on the smooth stepper. You got port 1 and port 2. I'm plugged into port 1, so that's the reason behind that if you're new to this type of software. Anyway, I got tired of messing around with the stepper motors, and that's why I ordered the servo drive. And I think with actually with an embedded operating system, this will probably work pretty well. I've done all kinds of retrofits with plasma tables and router tables using the stepper motors, but not any servos. This is kind of, I'm a newbie at this too, so just for your information. Okay, so we've set the ports and pins up in the motor outputs, so they should be ready to go. I'm going to hit reset, and at this time I should be able to use my arrow key. My left and right arrow key is going to be the x-axis, so let's push the right arrow key, and we're pulsing. Let's see if the motor's moving. Yep, moving pretty slow, but it's moving. Now, if I stop here, I'm 7 units out. If I were on a router table, plasma table, or a mil, whether that's millimeters or inches, that's up to you. But I'm 7 units out. So what I'm going to do is I'm going to send it back to 0. So I'm going to click right here, and when it goes back to 0, I expect those that tape I put on there to line up perfectly where I cut it with my razor knife. All right, let's give it a shot. it goes. And it's about 3 units out now. 2, 1, and 0. And there you go. So nice, accurate, closed loop feedback. Much nicer than steppers. But steppers have their purpose. If you have a load and you want to do higher speeds, though, I think Servo is going to be your answer. So now let's play around with one more parameter. Let's just go up to configure. I don't think I showed you this. And we're going to go to motor tuning. Now, like I said, these motors are pretty much plug and play, but what we're going to set up, this is where you set your mechanical drives up and so forth, and it depends, you know. This is how many pulses per unit it takes. The velocity right now, it's set at around 50 and my acceleration at 10. You don't want your acceleration too high, it'll cause the motor to jump and run pretty rough. You want a smooth start and stop. So let's ramp this up and get a little higher speed. Let's jump the velocity up to 200 and let's set the acceleration to about 30. And then we'll save the axis. Hit save axis, and there we go. Now, let's run the motor. And we're going even faster. And it'll go every bit of its 2,500 RPMs. It just depends on your load, inertia, and in other words, how much weight your gantry or whatever it is you're carrying with the motor, as to what you can get away with on those settings. You just kind of, some of it's trial and error. There are some math calculations you can get online and find and calculate, but as long as you don't exceed the design current and torque of the motor, this is very reliable positioning. So I'm pretty pleased with the purchase, and I wished I could show you a lot more about it, but I'm still learning myself, so that's all for now.